Hello, Algebra 2 students. Today we will be doing 8.5, add and subtract rational expressions. Let's do a throwback. Let's take it back to 5th grade. When we were to add fractions with unlike denominators, what did we have to do? We had to find a common denominator. And the only way to do that was to figure out a number that we would multiply both the top and bottom by each fraction to get that common denominator. So if you look at 4/7 and 3/5, the common denominator would have to be 35. So you would multiply top and bottom of each fraction by, or multiply the first fraction by 5, but multiply the top and bottom of the second fraction by 7. And so we got 20 over 35 plus 21 over 35, and that gave us 41 over 35. For the second fraction, or for the second problem, you do the same thing, but this time you have 3 fractions. But if you look at 2, 3, and 4, and I would just take the smallest number and skip count. So if you take a 2, 2, 4, 6, 8, 10, 12, 12 would be the common denominator. So multiply this top and bottom by 4, this top and bottom by 6, and this top and bottom by 3. So you would have negative 8/12 plus 42 over 12 minus 3 over 12. And then just adding those fractions together, negative 8, add just the numerators together, but leave the denominators alone. So negative 8 plus 42 minus 3 happens to be a positive 31. 31 over 12. What did you have to do in order to successfully add or subtract those fractions? We had to find the least, what is known as the least common multiple. That's what I meant by skip counting. So in algebra, where we have variables, you do something similar. So let's talk about finding the least common multiples algebra style. When variables are involved, what do you do? So in example number 1, you have no fractions here. So right now we're just figuring out how to find the least common multiples. So to find the least common multiples, you want to factor all the expressions if they are not factored. In example number 1, neither of those expressions is factored. So if you look at the first one you can factor out a 4, and then you're left with x squared minus 9, because if you were to multiply that out, you get 4x squared minus 36. You're not done. This is a difference of squares pattern. These two numbers are nice numbers that you can take the square root of. So you still have the 4 out here. Make your 2 parentheses. Square root of x squared is x. Put that in each slot. And the square root of 9 is 3. Positive times negative will always give you a negative. And that's the only way to get the 9, or the negative 9. That one's done. Let's look at the second one. Second one, you can factor out a 6 from every term. So you're left with x squared plus 6x minus 9. Okay. And now you want to, I'll do it right here, make an x factor. B is 6, a times c is 1 times 9, 3 and 3. And so I'm going to write that as 6 times x plus 3 times x plus 3 if it helps. For this, it might help to write it out twice. I'll show you why. Here's how you pick the least common multiple. So we haven't done anything other than factor it. The least common multiple, you look at the numbers separately from the factored expression. So you look at 4 and 6. Take the smaller number, which is 4, and skip count. 4, 8, 12. 12 is the least common multiple of the numbers. But what about the variables, the expressions? So if you look at x plus 3, it appears once there and once there. You always write the largest amount of times it appears. And so it appears one time in either one. So you write it out once. So x plus 3. And then, oh, I'm sorry. It appears twice here. So I didn't even see it here. So 2 is bigger than 1. So x plus 3, you could write it out times x plus 3, or you could just put x plus 3 squared. Okay. And then this appears once in the first expression and 0 times in the second. So the largest time it appears is at least once. And that is your least common multiple. And we are going to do another one. So in example 2, you can factor out a 3 out of this first expression. So you're left with x squared minus 3x minus 10, because 3 times negative 10 is negative 30. And then we are going to make an x factor for it. Let's see, b is negative 3, a times c is negative 10. Told you factoring would come back and haunt us in chapter 8. So two numbers that multiply give us negative 10, added give us negative 3, negative 5, and 2. So we have 3 times x minus 5 times x plus 2. First expression factored. Second expression, pretty simple, 6x plus 30. The first thing you always do is look for a greatest common factor, and they have a 6 in common. Factor it out, you're left with x plus 5. Done. Now we're ready to find the least common multiple. All right. So you look at 3 and 6. Always look at the numbers first if there are any. Skip count by 3, 3, 6. The least common multiple of the numbers is 6. X minus 5 appears only once in either of the expressions. X plus 5 appears only once, or x plus 2, sorry, and x plus 5. It doesn't matter what order you put these in, as long as you put them next to each other. There we go. And that is the least common multiple of example 2. Now that we know how to find least common multiples, we can finally add and subtract expressions. Here are the steps. Step 1, find the least common multiple of each denominator, but factor everything first. So maybe let's put an extra step in here. Factor the denominator if necessary. I always just assume that, but never assume. So factor the denominator if you need to. If you don't, then you don't factor it. That's an important step. That's why we did the LCMs of the previous two problems. Next, find the least common multiple of each denominator, like we did above. Multiply by what's missing to get the common denominator, just like you did in back in 5th grade. And finally, combine the numerators and keep the denominator. So don't do anything with the denominators. Okay, so the first thing we're going to do in example 1 is we're going to factor the denominator of the first fraction. You can easily recognize this as something you need to make an x factor for. Please don't write large here. You definitely need to write small for the first example and the third example. So our b is 5, a times c is 4, and 1 times 4 is 4, 1 plus 4 is 5. So I'm going to write this really small. So factoring the denominator of the first, we have 1 over x plus 1 times x plus 4. Okay. Second fraction, we do have to factor out a 3 in the denominator. And 3 times what gives us 3x? 3x. 3 times 1 has to give us 3. Now you are ready to list your LCM. I am going to do that right here. All right. So for the first fraction, x plus 1 appears once, and x plus 1 appears once in the second fraction. So it only appears 1 in either of those. Oh, geez, I forgot the number. I forgot the 3. Here we go. Because there is a number in front of the second fraction's denominator, but not in the first. So 3 is going to be the least common multiple of the numbers part. Then you have x plus 1, and then you have x plus 4. If you get this done, this is the hardest part. Everything else should be clear sailing. So look at our least common multiple that I wrote out. You have 3 times x plus 1 times x plus 4. Now let's look at the first fraction. This one is missing the So this, and it's always the numerator and the denominator. Okay, so we are going to, x plus 1 and x plus 4 in the denominator is missing the 3. So you put a 3 here, and you do the same thing to the top. Remember, you multiply top and bottom by what's missing. The x plus 1, x plus 4 is already there. Basically, guys, here's the real deal. This should be in your denominator of each fraction, because that's the whole point of finding the least common multiple. The second fraction, I'm going to write it down. Oops. What is it missing? It has the 3 and the x plus 1 in the denominator, but it doesn't have the x plus 4. So I'm going to multiply top and bottom by x plus 4. And you could put it anywhere you want, but I'm going to list it in order just because I think it looks better. So let's see, it already has a 3. It already has an x plus 1, but it needs an x plus 4. Oops, I wrote that wrong. I just wanted to use the same colors to show you what I needed to multiply top and bottom by. Yay, so both of those now have common denominators. So we combine the numerators, only the numerators. 1 times 3 is 3. I would make a gigantic fraction bar like this, since we're going to combine the numerators, but we're going to keep the denominator. So we have 1 times 3 is 3 plus 5x plus 20. We are done. We do not have to do anything else in this problem. Okay, next problem, least common multiple. We don't need to factor because notice there's nothing factorable in the denominators, but the least common multiple, x appears to the third power, so that's the biggest. I noticed that right away. And y appears only to the first power in either of those two fractions. So that's your least common multiple. The first fraction has everything, so you don't multiply top and bottom by anything, because look, in the denominator, it's everything. Second one, however, is missing. So this is missing an extra x squared. It only has one of them, but it's not missing a y. Okay, so that would be plus 2x squared over x to the third y. Here we go. And now we're ready to combine the numerators. So we have 5 plus 2x squared all over x to the third y. Okay. We will do one more of the addition and then we'll do some subtraction. So doing example number 3, and we have room here, so we can spread stuff out. So this, we're going to factor, x factor. B is -4. A times C is -12. Two numbers that multiply give us -12. Added give you -4, -6, and a +2. And this lovely second fraction, you could factor out a 4. So let's go ahead and at least write what we have. 1 over x minus 6 times x plus 2 plus 3x. Factor out a 4 from the bottom of the second fraction, and you're left with x plus 2. I absolutely love factoring, and it just really helps to do the problem, or else we can't even tackle it. So now we're ready to find the least common multiple. Of the numbers, it's 4. X minus 6 appears once. X plus 2 appears once. So that is your least common multiple. And so we are going to multiply the first fraction, top and bottom, by only 4, because that's what it's missing. So I'm going to do that. 1. It already has the x minus 6 and x plus 2. Second fraction, what is it missing? Well, it has the 4 and the x plus 2, but it's missing the x minus 6. So 3x times x minus 6 over 4 times x minus 6, or you could put it at the end, but if you want it to go in order, put it the x minus 6 now, times x plus 2. And now the denominator has everything it needs to have the least common multiple. And now we're going to combine the numerators. So 1 times 4 is 4, plus 3x squared, I'm going to distribute, minus 18x, all over. Never, ever multiply the denominators. Or just write them next to each other. Sorry, that's not what I meant. Never multiply any of it out. There we go. Hopefully that hasn't been too painful. As long as you just remember to treat it like you normally would if it were regular numbers that you learned back in 5th grade. Okay. And just to kind of give you a heads up, we are not going to do these simplifying complex fractions because you literally will cry, because this is true. And if I probably would do it if we were in class, but no, we are not going to do that. So you can cross out this entire thing. I will not test you. It's not on your homework. Let's do 2 more problems. Subtraction. So same process. Factor the denominators. You know what? I don't know why I'm making an arrow, because you don't have to make an X factor chart for that. There's only 2 terms. So got ahead of myself. Okay, but we can factor out a 5 from the bottom. Write small here. So factoring out a 5 yields us y squared minus 5 times 1 is 125. It is 25. Remember, there's a minus sign between them. 4 over, factor out a 3, and you're left with y plus 5. We are not done factoring the first fraction because this is a difference of squares pattern. Have to be able to recognize these things. So 7y over 5 times, difference of squares pattern has 2 sets of parentheses. Square root of y squared is y. Square root of 25 is 5. One's positive, the other's negative. Second fraction is completely factored now. We are ready to list the least common multiple. So I kind of wrote really large, which is pretty bad, but that's okay. I'll get over it. So least common multiple based on the fractions that we just factored. Okay, let's look at 5 and 3. We'll skip count by the smaller number. So 3, 6, 9, 12, 15. So 15 is the least common multiple of the numbers. And y plus 5 appears once. Y minus 5 appears only once, and that's in the first fraction. In the second, it doesn't appear at all, so 1 is bigger than 0. All right. We are ready to multiply the numerators by what is missing. The first fraction is missing, well, it has the 5 there, but it doesn't have 15, so you want to multiply top and bottom by 3. And honestly, guys, I'm going to do this. Save myself some room here, since I wrote so big. So now, notice the denominator has 15 in it. The second fraction only has a 3, and it has a y plus 5, but it's missing a y minus 5. Make sure you have y minus 5 in top and bottom. And it's missing, it only has a 3. It's supposed to have 15, so you have to multiply top and bottom by 5. There we go. And now it has 15 in the denominator. Now we're ready to write the denominator. So we have 15 y plus 5 times y minus 5. Tops, we're going to combine. 7y times 3 is 21y. Be really careful here, guys. You want to multiply 4 times 5, which is 20. So we have minus, this is 20 right here. So 20 times y. So minus 20y. And again, be really careful. You have that same 5 times 4, which is 20, and you're going to multiply it by a negative 5. That's a negative 100. But guys, we have this minus sign. So a negative times a negative will be a positive. Now, can you leave your answer like this? No, because you have to combine like terms. 21y minus 20y is 1y. And then you have the denominator. So over 15 y plus 5 times y minus 5. And one last problem. Okay, so we are going to x factor this. Well, we're not going to x factor it yet. We're going to factor out a 3 because they all have a 3 in common, leaving us with x squared plus 12x plus 35, because 35 times 3 is 105. And the bottom of the second fraction, you could just factor out a 6. Let's continue factoring this one. So then you make an x factor for the remaining stuff. 12 is b, a times c is 35, 7 and 5. So at this point, you have negative 2 over 3 times x plus 7 times x plus 5. Second fraction, piece of cake. Factor out a 6 from the denominator. It's the largest one. You don't want to factor out a 3. Always factor out the biggest number you can. So 6 times x plus 5. Right, now we're ready to list the LCM. And I have room, so I'm going to just list it down here. So out of the numbers, 3 and 6, skip count by 3, 3, 6, 9, 12. Well, 6 is the least common multiple. So 6 out of the numbers, x plus 7 appears once, x plus 5 appears once. Right? What is the top fraction? What is the first fraction missing in the denominator? It's missing the 6. It only has a 3. So you want to multiply top and bottom by 2. And now it has the magical 6. The bottom fraction the second fraction has a 6. It has an x plus 5. It's missing the x plus 7. So multiply top and bottom by x plus 7. There, boom. And now we can combine the numerators. Negative 2 times 2 is negative 4. Minus, so we have here 3x squared. And then 3x times 7 is 21x, but it's a negative, remember. Negative 21x. All over 6 times x plus 7 times x plus 5. And this is how we add and subtract rational expressions. And those are your notes for today. Have a great day, Algebra 2 students.